go.
Hi, I'm Ryan in grade 4. This is my Scratch project. It's breakout.
That program I made in grade 4.
Hi, I'm Yusra and I'm in grade 4 and I made this program in Scratch that is like a game of Mario, and the good things about it is that it can when it gets to the end of the screen that it can go to the new place. And the goal that I'm trying to get to is that it cannot go on top of something if it runs into it.
I hope you enjoyed hearing from my students as I attempt to push my unit to the next level, from a theory in use to a theory in action, as change theorist Michael Fullen suggests. However, before I begin describing what my curriculum unit is all about, let me just simply say what it is not. It is not a technology curriculum. It is meant to be a learning and thinking plan. It's not actually designed to teach Scratch itself, but in fact to utilize Scratch to transform the thinking of others. Okay, so on to our framework. So I use the Understanding by Design framework, the backwards design framework for our particular unit, and I'm going to explain why right now. As you can see here on the screen, we have software at our school called, it's curriculum mapping software by a company called Atlas Rubicon. And what this will allow you to do in many sophisticated ways is just simply develop curriculum, share curriculum for dialogue, and it is a very powerful tool for collecting curriculum and, most importantly, analyzing it and attempting to upgrade and make changes when necessary. So I use this software to develop the curriculum for my curriculum unit plan, and as we go in, you can see that I've used the backwards design framework because it's basically here, and that starts with stage 1, which is identify the desired results. So I'm just going to go through it. Okay, so let's look at the learning goals here. The learning goals were divided into 4 particular categories: knowledge, reasoning, skill, and product. And I borrowed that from Marion Duerk's work about grade smarter, not harder. And as you can see here from here, they're quite learner-centric. They are, and I'm going to attempt to say this, they are phenomenological, which basically is a fancy word for saying that they're looking from the individual outwards to the world. So if possible, we're trying to encourage the self-actualization of the learner. So Maslow's theory is very, very critical importance here. And I have a quote here from one of the groups here that said, self-actualizers also have high creativity. And I think this is why the shift is happening in primary grades to focus on inquiry and starting units with questions students have about a topic. And the shift to giving students the choice of a product to show their learning when being assessed, i.e. create a presentation, writing, or demonstration, or in this case, a computer program. So in other words, self-actualizers are described as people who have empathy for others and generally want to help out the world. And as you can see, one of the product goals is eventually the ability to solve curricular challenges, and if possible, stretch beyond to solve world problems. And I think that's where we get into some interesting areas where social reconstruction theory possibly could be brought into this curriculum document here. One example is one student here created a Scratch program to help others learn another programming language. And there's a quote here that says, because Scratch programs are shareable, students can use Scratch to provoke discussion of important issues with other members of their immediate learning environment, as well as the wider international Scratch community. So again, it's creating dialogue and the potential for social change through that dialogue, which is quite powerful. Okay, so moving along, we've got our essential questions here on the right. And as you can see, again, they're sort of moving up the hierarchy from the individual eventually out to society. And what we're really essentially talking about in this curriculum document is the idea of computational thinking, which is not just learning Scratch, but learning how to think, to manipulate using technology, computer programming, in order to do amazing things, great things that could not be done without it. Okay, so that leads us into our topic and some of the headings here. And pay attention, one that's kind of interesting is the idea of remixing, because later that'll come up when we talk about just ownership of materials and copyright, and how that Scratch has a very interesting way of dealing with that, which is that the remix is celebrated is for grade 4 and 5 students. And what I'm attempting to do with this curriculum document is to try and make them become independent and self-directed as much as possible. And as you can see, this goes through some of the success criteria of what exactly we want them to do by the end of this unit. And one of the things that I really like about this, and we'll talk about it later, is a design journal, because that encourages reflection. Okay. And again, there's some vocabulary, and now we get into some more of the strategies for teaching this particular unit, of the role of the facilitator or teacher. And I think that, as you can see through the direct instruction here, these are more traditional, but very quickly we get into interactive instruction here, where we got brainstorming, partner, discussion, and this is where we really rely on the ideas of free day, where we have dialogical teaching being involved there, and dialogue between the student to teacher, student to student, and maybe even student to expert outside of the classroom. There can be lots of opportunities there. On to the teaching strategies on the right hand of the screen here. You'll see that this is a sort of a list of activities from 1 to 10 that they would be following through, and there's both a teacher's guide and a learner's guide, which are at the bottom of this particular document as attachments. And as I mentioned before, the idea of a design journal is quite interesting, because it follows with the sort of accompaniment model idea that LaFortune's book, the textbook we've been looking at, in the same way that we adopt, or the learners adopt a reflective stance, the students in this particular situation can do so as well. And again, looking towards number 10, the last project is sort of neat, because they can either showcase their favorite project that they've done so far, and again, the projects are in sort of 3 categories, which we'll talk about in a sec, but games, stories, and animations. Or they can, really, if they're really in that self-actualization stage, they can, create something that's never been done before. But again, considering the age of the particular students, there also has to be scaffolding involved, so that they can that they are able to just copy the idea of a project that they can iterate or change and make and modify to make their own. And also, since we're talking about new projects and things, I think that you could have the possibility of the SAMR model, the different phases of the SAMR model being employed here. Obviously, we're not looking at the substitution stage of the SAMR model, because a computer program is very different from other formats. But eventually, you could move towards a redefinition, where you're creating an interactive game that celebrates the learning objectives or a student's achievements in a particular area. One example was in science. A number of students created a science game to learn different parts of the body, and they created sort of a game and a narrative about it, which I thought was pushing towards the redefinition stage in the SAMR model. Okay, so moving on. Okay, so now we're getting into our assessments here, and again, free day was a huge influence here, because I'm problematizing a number of things. I'm saying, hey, can you create an animation using Scratch? And we talk about examples from, we showcase examples from various other programs here. There are some video tutorials that they can use, and there are also some step-by-step guides that they can make use of in order to follow through with these particular assessments. And the same thing with the narrative. As you can see, it's quite open-ended. So what's really great is that the teacher can bring their expertise to a particular project, but the students are bringing their creativity, and each one is completely unique because they're open-ended: game, story, animation. Students can bring their unique voice, regardless of race, regardless of sex, regardless of class, regardless of background, and even perspective. The only backpack here, in reference to the backpack that we all carry of our privileged background, is one that students can use to transfer code, which is the building blocks of programming, from one project to the next. So I think this is a very powerful idea that that transcends and makes these assessments applicable to any student regardless of their background. Okay, and again, this just reiterates some of the different strategies that are available for educators to help students. There's the video tutorials. I've created sort of a document here that if I click on it here, you can see, oh, I'd have to log in. Hang on. Oh yeah, I can do this quick. Oh yeah, here we go. These are all tutorials, and basically if I click on one of those would all be video tutorials that students could follow. Okay. One of the other things I really like in this guide, in this curriculum document that we've been using, is the idea of critique groups. So for instance, when students get to a certain stage in their project building, they can actually work within teams and critique each other and help each other with their particular projects. So it becomes kind of a shared project. So one person is responsible for their own individual creativity, but they obviously can leverage the ideas and critiques of others. So very important that the teacher promotes a positive environment, talks about strategies about how to help others without stamping on their creativity, and allowing them to share their voice in their projects with as confidently as possible. And obviously, depending on the level of understanding and interest on a particular topic, I also have what I call recipes, which are very simple Scratch programs which students can make use of. Okay, so on to the 21st century here, and I mentioned this before about the idea of Creative Commons, which Scratch does a really good job, the idea of the remix on the 21st century skills. And moving on to our resources here. Obviously, I've focused completely on Scratch, but there's a number of other different tools here that can be used as well. Code.org has an incredible site with courses that have been designed that I've used with students that I have used with, it would be a different unit for grade 4 and 5 where they can program. There's a number of playlists and videos that I've mentioned here, posters around the room as you saw in the video, cards. My whole room is really decorated with resources to help learners, and I think we really have to reference, or it's very responsible for me to reference the idea and philosophies and ideas of Seymour Papert. He created the logo language that maybe a number of you were familiar with or have come across in your travels in education. And obviously his theory was a constructionism theory where students understand the world by constructing around them, and he felt logo was an important way to do that. And Scratch is kind of its natural successor, and that was designed by an MIT professor called Mitch Resnick and his research team at MIT. Very appropriately, the last part of my curriculum unit plan is all about critical thinking. And as you can see, I am a big fan, or want to use the design cycle and design thinking, which helps students design with purpose, but also gives them some room for experimentation to inquire and plan and prototype. I also want to encourage them to be self-directed learners, as much as possible for them to find ways to solve problems using the resources that are available to them, each other, and potentially experts in the field. And on a good day, that expert is me. So I try and help as much as possible. So thank you very much for listening. I think one of the greatest opportunities for this particular unit is that I can really learn alongside students, which I really like. And this curriculum document was really possible from the academic research learned from this course, and also the feedback and expertise from all the colleagues has been really great resources for developing good pedagogy and sound research. So thanks to all of you, and I think appropriately we'll end with a little Scratch program that I designed here that's going to say, thanks so much.